If you've ever managed a server or pushed code to GitHub, you've definitely used SSH. But have you ever stopped and wondered how it actually works? How does it keep everything so secure? Well, in this explainer, we're going to pull back the curtain and really demystify the magic behind Secure Shell. To really get why SSH is such a big deal, we first need to look at what came before it: Telnet. Now, think of using Telnet like sending a postcard. It's wide open. Anyone who happens to grab it along the way can read your entire message. SSH, on the other hand, is a completely different story. It's like a locked briefcase. Only the person with the specific key can open it and see what's inside. This quote just nails it, doesn't it? With Telnet, literally everything you send, your username, your password, every single command you type, is just sent in plain, readable text. Anyone listening in on the network can see it all. It's a huge, glaring security risk, which is exactly why you almost never see it used anymore. So in comes SSH, or Secure Shell, to save the day. Its entire purpose, its whole reason for being, is to fix that massive problem. It creates a secure, private, and totally encrypted conversation between your computer and some remote machine, even if you're connecting over a public, insecure network like a coffee shop Wi-Fi or just the internet in general. And under the hood, this secure conversation usually happens over a specific digital doorway, TCP port 22. It's the standard, which means most firewalls are already set up to leave this port open, letting all that good SSH traffic pass through, while still blocking other potential threats. So we know SSH creates the secure connection, but how? How does it actually do it? This is where the really cool cryptography comes in, and it all kicks off with what you can think of as a very clever secret handshake. The first part of this handshake uses something called asymmetric encryption. The best way to think about it is like having a public padlock and a private key. You can make copies of your open padlock and give it to anyone. They can use it to lock a box, but, and this is the important part, only you, with your unique, one-of-a-kind private key, can ever unlock it. It's incredibly secure and just perfect for setting up that initial connection. Now, while that asymmetric method is amazing for starting the conversation, it's actually a bit slow for a continuous back-and-forth chat. So once that secure link is established, the whole system cleverly switches to a much faster method, symmetric encryption. For this, both sides use the exact same shared secret key to lock and unlock the data for the rest of the time they're connected. It's just way more efficient. Okay, now what is just so cool here is step 3. This is the real magic of the whole process. Using a very clever algorithm, both the client and the server use that initial public key handshake to independently calculate the exact same shared secret key. So the key for the main conversation is never actually sent across the network. Someone could be listening to the whole negotiation and they still couldn't figure out the secret. It's absolutely brilliant. Okay, so the tunnel is secure, we're good there, but the server still needs to know who you are. The next step is authentication, where you prove your identity. And no surprise, SSH has a way better method than just a simple password. I mean, you can use a password with SSH, but honestly, it's like putting a cheap bicycle lock on a bank vault. Passwords can be guessed, they can be stolen, they can be brute forced. SSH keys, though, are a whole different level of security. They're incredibly complex, they let you automate logins, and, most importantly, they prove who you are without ever sending your secret across the network. So how does this dance work? Well, your private key, your digital identity, it never, ever leaves your computer. The server sends you a little puzzle, a random challenge message. Your computer then uses its private key to sign that message and sends the solution back. The server then uses the public key it already has on file to check if the signature is valid. If it all checks out, boom, you're in. It's a fantastic way to prove it's you without ever revealing your secret. Now, I know this might all seem a bit abstract, but I guarantee you're using this exact technology all the time, probably without even realizing it. So let's look at a couple of real-world examples where SSH is working its magic right behind the scenes. Ever launched a cloud server on Amazon Web Services? You know that .pem file they have you download? Yep, that's it. That's your private SSH key. AWS automatically puts the matching public key on your new server for you. So when you connect using that file, you're doing the exact key-based authentication we just talked about. And what about version control? If you've ever set up your computer to push code to GitHub without having to type your password every single time, well, you've used SSH. You upload your public key to your GitHub account, and then your Git client uses your private key on your machine to authenticate every push, all seamlessly and securely in the background. So Beyond secure logins and file transfers, SSH has this sort of hidden superpower that is just incredibly useful for developers and sysadmins, and that is the ability to create secure tunnels for other applications. Let's frame this with a really common problem. Imagine you need to connect your local application to a database. But for security reasons, that database is running on a private network and you can't access it directly from the internet. So how in the world do you get to it? You use an SSH tunnel. It's so clever. You basically tell your local machine, hey, any traffic that comes to this port on my machine, I want you to securely wrap it up, send it through an SSH connection to a server I can reach. That's often called a bastion host. That host then unwraps the traffic and sends it along to the private database. So your app thinks it's just talking to a local database, but really, SSH is securely shuttling all that data back and forth behind the scenes.
This technique is an absolute game changer. It means you can securely access pretty much anything on a private network, from databases to internal admin dashboards. You can use it to get around restrictive firewalls, and you can even use it to wrap an old application's traffic, one that doesn't use encryption, inside a secure SSH tunnel, giving it an instant security upgrade. So from that initial secret handshake to proving who you are and even creating these secure tunnels for other programs, SSH is really the silent workhorse that powers so much of the modern internet. It's so much more than just a remote terminal. It's a fundamental tool for security. So the only question left is, now that you know its secrets, what are you going to build and protect?